Good morning, friends. Today I will be talking about a geospatial pipeline that is used to uncover the ancient Amazonia, to uncover the hidden archaeological sites within the Amazon rainforest using OpenAI. I have integrated diverse datasets and advanced analytical techniques that helps to revolutionize the archaeological perspective in one of the Earth's most challenging environment. I have used a lot of datasets that helps to predict the nature or the archaeological sites. For example, I have used satellite imagery that helps to broad spectrally analysis and help for temporal depth and radar and SAR data. By integrating these data sets to it helps to penetrate the densest copy and assesses the soil moisture for the obscure areas. Third one is the terrain models that helps to compute the slope, curvature, topographical positions, and the rugged indexes. We will be talking later on what type of indexes I have used. So let's talk about the synthetic data. I have used synthetic data that is generated from the images that are provided datasets. For example, Sanital 2, SR Harmony, Sentinel 1. From these type of images, I have generated synthetic data. So I have used advanced spectral indexing and anomaly detection in spectral indexing. We have firstly we will talk about indexing, what type of indexing I have used. So mainly I have used four type of indexing. First one is NDVI, that's normalized difference vegetation index. It helps to measure the green vegetation density. And second one is the anthropogenic vegetation index. It highlights changes caused by the human activity. And MSI, moisture stress index, it indicates the plant's water stress. And fourth one is NDVI, normalized difference water index. It helps to measure the surface water content. Why have you used? Each index reveals different aspects of land vegetation response. It identifies irregular patterns in plant growth, moisture, or water, which can suggest buried structure or past settlements. So, temporal, let's talk about anomaly detection. It helps to subtract the index values between the time period that's I have used, for example, from 2020 to 24. It's sudden. Why I've used its sudden change in vegetation or the human impact may reveal recent deforestation, soil exposure, or disturbances. It helps to predict or highlight new suspicious changes not due to seasonal cycles or natural causes. So one thing I will be talk about that how I have used these images. So I have divided the Amazon region into 25 into 25-kilometer regions that helps to intersect with the rainforest boundary. A uniform grid system dividing the rainforest into manageable spatial units. It enables the scalable parallel processing and spatial comparisons, making it easier to aggregate, analyze, and visualize data cell by cell. So let's talk about the geometrical analysis and terrain suitability and assessment. So four grid cells showing high archaeological potential that's greater than five. The in my project, let's say seven. It's the highest potential. That's advanced vision techniques that were deployed to identify the subtle man-made patterns that are typically missed in broader scans. I have used the canny edge detection to identify the sharp changes and whole lines to detect the straight line indicating the roads, canals, or the rectilinear foundations, and circular fitting to identify the circle pattern suggesting enclosures. Let's talk about the terrain suitability. Digital elevation models from SRTM and LiDAR were crucial for understanding the landscape suitably for ancient settlements. Metrics like slope, curvature, TP, and TRI were computed to identify the favorable topographies. I have used the interactive visualizations and the site reportings to predict or visualize uh, the area very well. So I have used the Polymoly Flat Map Explorer to display the archaeological heat maps, and I have created visual reports as well of particular areas that are having high potential. So I have talking about AI. What special I have done using AI. So I have firstly used to create generate synthetic data, and I have used random forest classifier as a training model. So basically, I don't use a single approach. I have used multiple approaches to reach our destination. I have taken care of quality checks as well. So my project is scalable and deployable system for the real world. It integrates with the asynchronous exports, batch processing, and modular design, and helps the world to get a lot of information about my project, or say about the Amazonia project.